On our 9.6 lesson, we need to solve more of our rational equations with these polynomials. So, again, remember the first thing to do is always find our LCD. So we have x minus 2 over here. So x minus 2 is our factor. Over here, x squared plus 2x minus 8. So our factors are going to be x minus 2 and x plus 4. And over here we just have x plus 4. So this one shouldn't be too terribly difficult. Our LCD, we have an x minus 2, that's over there as well. X minus 4s as well, in each case only occurring once. So our LCD is just x minus 2, x plus 4. Well, let's get rid of this. Move down some. We need to multiply each one by that LCD. So we get x minus 2, x plus 4 times 1 over x minus 2. That's our left side of the equation. The right side of the equation has, again, the x minus 2, x plus 4 times the amount 2x plus 1 all over. I'm going to write this in our factored form, x minus 2, x plus 4. And the last fraction here, x minus 2, x plus 4 times the original piece was 2, the numerator, and our x plus 4. Looking a little bit dirtier at this point, but we can clean it up, get rid of the x plus 4, get rid of the x minus 2 and the x plus 4, and get rid of the x minus 2, which in the end leaves x plus 4 times 1 is just x plus 4 equals, there's nothing left here but that 2x plus 1 plus x minus 2 times 2, 2x minus 4. So this is our equation at this point. Now, we can combine some like terms. We'll leave over here our x plus 4 equals 2x and 2x become 4x. 1 and negative 4 become negative 3. So from here, we would say add 3, minus x, 7 equals 3x. So we just solve for x and say that x is then 7/3. So this would be our only answer, but now we need to check it and make sure it works. So it's x is 7/3 was our answer. And if we check it by plugging it into each of these pieces, none of them will come out to 0. So it does check out, and this is our only answer. X equals 7/3. Now we need to move on to looking at solving rational inequalities. Now, they're going to be pretty much the same as our rational equations, except for because they are inequalities, the answer is actually going to be graphed out on a number line. So, first thing to find is we need to state the excluded values. So the things that are going to make one or more of the fractions have a denominator of 0. Those are part of our critical points. Solve the related equation, any solutions, those are going to be the rest of our critical points. So all of this are our critical points. We use those critical points then on our number line. So let's say we had one solution and one place that it became undefined. So those would be our points. Then the only thing left to do is test points within there. And if they check off, or if they don't check off, we shade where they're checked off, and we don't shade where they're not checked off. Then to determine whether or not we circle them in, if it was a spot where it would make it make the solution be or have a denominator of 0, that has to be open. If our equation then has a less than or equal to or a greater than or equal to, then it would be filled in. Or, let's say it was a greater than or less than, in that case, at that solution point that you found, then it would have to be open. So let's see how it looks when we actually solve one of these through. If we have 1 over 3s plus 2 over 9s is less than 2/3. Well, first thing to do is always find the LCD. So we have 3s, 9s, and 3. So 3 times s, 3 times 3 times s, and 3. So it looks like all of these have a 3. All of them have an s. S is to the first power, 3 is to the second power. So our LCD is 3 times 3 times s, or 9s. So we need to multiply each of these by 9s. So 9s times this, 9s times this, 9s times this. Solving this through, 9s over 3s just leaves us with 3. 3 times 1 is 3. 9s over 9s, that cancels out. Actually, I'm just going to show you where each of these went. So we're just left with 2 here. 9s over 3, the 3 and the 9 leave us just a 3. 3 times 2 is 6. We're going to change it to an equal sign. Instead of leaving that less than, we'll change it to equals and say equals 6s. Now, 3 plus 2 is 5 equals 6s. Solving for s then, 5/6 equals s. So 5/6 is our first critical point. Now, looking back at this equation, what values of s would make it 0 in the denominator? Well, there's only one. That's where s equals 0. So 0 is our other critical point. So we'll say 0 is one critical point, and we'll say 5/6 is a critical point. Now we need to test those points in each of those regions. So I would say then a good one to test over here would probably be -1. It's nice and easy to plug in there. A good one to test in here would be 1/3, because we're using all values of 3. And a good one to test over here is 1, because 1 is, again, just a nice easy value to plug in. So, oops, undo that. Just move some of this work off to the side. Let's plug in -1 first. So 1 over 3 times -1 plus 2 over 9 times -1 is less than 2/3. Well, this is going to be a negative number. This is going to be a negative number. Negative plus a negative has to be a negative value, and any negative value will be less than a positive. So, -1 is true. That is a true place to be. Now, if we look at 1/3, 1 over 3 times 1/3 plus 2 over 9 times 1/3 is less than 2/3. This one we're going to have to actually solve through everything. 1/3 of 3 is just 1. 1/3 of 9 is 3. 1 over 1 just becomes 1. So we have 1 plus 2/3, so 1 and 2/3 is less than 2. Well, that is not true. So, oops, this isn't negative, just 1/3 is not true. And the last one we need to check is 1. So let's set that all up. 1 over 3 times 1 plus 2 over 9 times 1 is less than 2/3. 1/3 plus 2/9 is less than 2/3. Well, we're going to have to change all of these into ninths just so that they all fit. So 1/3 becomes 3/9. 2/3 becomes 6/9. 3 plus 2 is 5/9 over here. 5/9 is less than 6/9. Well, that is true. So 1 actually makes a true statement. So, oops, we know that, I'm going to use blue actually. The area for 1 is true. The area for -3 is not true, so we leave this blank. And the area for -3 is true. 0 was found because it couldn't equal that point, so this has to be open. 5, 6 was found because that was a solution, but remember, our equation is not a less than or equal to, it's just less than. So that has to be open as well. So our number line solution is going to look like this. The points at 0 and 5, 6. Moving on to our last equation here, our last example. We have 1 over x plus 3 over 5x is greater than 2/5. So, as always, first thing to do is find the LCD. We have x, we have 5 times x, and we have 5. So obviously, our LCD is going to be 5x. Nice and easy. So multiply everything by 5x, 5x, 5x. And we see that the x's cancel here, the 5x cancels here, and the 5 cancels here. So our new equation then becomes 5 plus 3 is greater than 2x. 5 plus 3 is 8, is greater than 2x, which then means 4 is greater than x. So our solution, oh, actually we should have used an equal sign here. Our solution is going to be 4. So that is one critical point right here at 4. Now, going back to our equation here, what values of x make it 0? Well, we have x, and we have 5x, so the only ways that we'll do it would be where x is 0. So that's our other critical point here at 0. And because we know right off the bat that this one was undefined there, this was a greater than but not equal to, so both of them have to be open circles. Now, it's just as simple as plugging in our values. So again, I'm going to use -1, 1, and 5. Nice, easy values to plug in here. -1, 1, and 5. We just need to see if they are true. So for -1, we'd have 1 over -1 plus 3 over 5 times -1 is greater than 2 over 5. 1 over -1 is -1 plus, this one's actually going to change to -1/5 minus 1/5 is greater than 2/5. Negative and negative can never be greater than a positive. So this is not true. Should say not T. All right, moving on to checking for 1. 1 over 1 plus 3 over 5 times 1 is just 5. Greater than 2/5. Well, 1 over 1 is just 1. And we're adding a positive value. So 1 and 3/5 is greater than 2/5. That is for sure true. So that piece works. Now we'll check our last one of 5. 1/5 over 3 25ths, because 5 times 5 is 25. It's greater than 2/5. Well, to check and be sure, we have to change all of these to 25ths. So I'm going to change this from 1/5 to 5 25ths, so multiplying by 5 over 5. Multiplying this by 5 over 5 gives us 10 over 25. 5 plus 3 becomes 8 25ths, greater than 10 25ths. I don't think so. Not true. Which means the 5 area is blank, -1 area is blank, and the only place shaded is where we had 1. So this would be the graph, the equation. This is our solution for our rational equation.